Okay, it is now exactly 12 noon, and welcome back to our this week's installment of our Virtual Water Ambassadors program. This is a program that is put on by Martin County and UF IFAS Extension. And the extension people that are involved in this are myself, Vincent Encomio, and Lisa Krimsky. Lisa is on vacation this week, lucky. And so I'm here to help host our guests for today. And I'm going to do a quick introduction if you haven't already been with us. But if you can see on the right hand of the slide there, those are our next round of presentations. We are going to have weekly presentations every Tuesday all the way through August. So August 25th is our last Water Ambassador webinar for our fiscal year. So and we'll see what kind of format we can go back to or continue as we deal with COVID-19, but we're very pleased with how this has turned out. We've had a great variety of guest speakers. We're lucky that Dr. Bean is back for another presentation, and I think you're really going to enjoy it. So just to get into some particulars, we're asking everybody to make sure they're muted, and also it helps with the bandwidth if your video is off. I'm going to do likewise when Dr. Bean starts, is turn off, mute myself, and also turn off my camera. And you can see at the bottom of the screen that black bar that shows all the different features there. One thing that you will want to use, and we'll save this towards the end, is the chat box for any questions. You can type in your questions anytime, but we'll get to them at the end of the presentation. I also want to also let you know that this presentation is being recorded using that record button. And we will post these presentations on our website at Martin County, UF IFAS Martin County Extension. So let me see. Yeah, there we go. So yeah, we'll just, you can see who's here by clicking on the participants list. Again, use the chat box to ask your questions, and we'll get to them at the end of the presentation. And you can choose any number of different options to view. I like to put everything to the side so that I can see the slides as large as possible. Again, here is the website where those recordings will be available. Sometime during the presentation, I will copy and paste that web address into the chat box so that you can access that directly. I expect this presentation, the recording of this presentation, to be probably up at least by the end of the week, and certainly by next week. But if you've missed any previous presentations, they're all listed there on that. They're all on those websites as a clickable Zoom link. Again, just as a reminder, please use the chat feature to ask questions. And our guest speaker back with us again is Dr. Eban Bean, and he's here to talk about his work on green infrastructure. It's kind of to introduce that concept of green infrastructure and low impact development. And this is particularly important in the context of the Water Ambassador program, in that we're trying to show and provide potential solutions to our stormwater issues in Martin County, and certainly as it applies to Martin County, it applies broadly in the rest of Florida. For the most part, and in the rest of the country. So I think this is going to be a great presentation, and I'm glad everybody's here. And with that, Dr. Bean, I'll let you take it away, and I'll go ahead and stop sharing my screen.
Sounds good, Vincent. Thanks so much. Glad to be back. Looking forward to some of your questions, and Looking forward to presenting to you today an introduction on low impact development to address some of the stormwater runoff issues that we have. Just to kind of give you a background, I'm in the Ag and Biological Engineering Department, have a position that's split between research and extension. So we're always looking at working at in urban water resources issues, whether it's stormwater management is one of the main areas, but also looking at some aspects of water conservation in urban areas as well. It's kind of that whole water cycle in the urban realm. So just kind of an overview. Just wanted to give everybody sort of a primer on stormwater runoff and management before we get into how to approach low impact development and the green infrastructure approach. So we'll talk about some of that terminology. You've probably heard different phrases, and we'll kind of try to explain a little bit of that or kind of talk about how they kind of come together. Then we'll go over the LID approach and then talk about some of the specific examples or practices, LID, green stormwater infrastructure, best management practices, go into some of those, and talk about how they function and the requirements for maintenance that go along with them, considerations that need to be accounted for. And then we'll kind of cover a couple of resources that I'll make available to you. Some of them I'll have links to, and I'll post in the chat. And we'll finish up with some questions. Okay, so just to kind of give you an introduction on stormwater management and the impacts of urbanization. Whenever we're kind of dealing with a land use or a land cover that's not developed, that condition of the land use essentially dictates what happens to the rainfall that falls on that site. And this is probably not a foreign concept. So in this case, what I'm showing here, a forested area, and this is a conceptual water balance here. This is sort of that pie chart that shows what happens to that rainfall that falls on the site. In this case, we have an example where 50% of that might be going into the ground and really going into deep recharge into the groundwater. 40% might go into the ground, so the trees and other vegetation may be taking that back up and then putting it. Maybe start to increase the impervious cover, roadways, sidewalks, anything that basically prevents water from infiltrating into the ground. We are reducing the amount of infiltration as well as evapotranspiration. And so that it gets shifted into runoff. So here we've gone from 50% infiltration to 42% infiltration. We've reduced our evapotranspiration slightly and increased our runoff by 10%. As we get into more and more developed or higher density, this might be like a typical residential neighborhood, 30 to 50% imperviousness. We are further reducing and shifting that water balance, less infiltration, evapotranspiration, and greater runoff. And if we have a really highly urbanized area, you can think about the downtown core or a major metropolitan area. We really push it to the extreme there. Now, it may look here from the transition of undeveloped to highly developed, or 75, 100% imperviousness, that we go from 50% infiltration to 15%, and we go from 10% runoff to, let's say, 30 or 55% in one of these last two cases. That's only a 20 or 45% increase. But if you think about it proportional to original runoff, there's actually a great increase. We have 3 times or 5.5 times the amount of runoff that's coming off that site. And so we have to do something with that. So this is conceptual, these numbers here. But this is also sort of looking at the overall water balance that might occur throughout over the course of a year. Okay, many storms. If we look at it just on a typical storm basis, what happens to the response of that watershed to the runoff, here we have sort of a typical rainfall event here with the blue bars, and the response curve, or how flow comes off of that watershed or discharges from that watershed in an undeveloped versus a developed setting. So if we see that we shift from this green response to this orange or red response, there's several things that occur. Number one is that there's a greater volume of runoff. We saw that sort of in the pie charts where we increase the imperviousness, we have greater amount of that rainfall that's actually going to runoff and leaving the watershed at the surface. We have a shorter time to peak. So what this means is if you look at the peak intensity of rainfall here, the peak of the undeveloped runoff might be here, but now we've shifted it to the developed, and now it's about, it's much quicker after that peak intensity of rainfall. This is due to the watershed not having the ability to kind of absorb and slow down that water as it moves through the watershed. Particularly when we urbanize an area, we are very efficient and effective at connecting our developed areas to getting that water off site. And we'll kind of talk a little bit more about that in a moment. And then we have sort of just a higher peak runoff rate. So you see the runoff rate here for the developed runoff versus our undeveloped. So we're increasing that as well. That has a lot of implications with flooding that I'll talk about in a moment. So if we consider sort of our just examples of the connectivity that we see in our urban areas, like I said, we're fairly efficient at routing stormwater off of our sites and getting it into our nearest waterways. So oftentimes we'll see that we have scuppers in the upper left-hand corner where rainfall off of rooftops gets routed into gutters that might go straight into a street, completely bypassing our green areas or our vegetated areas. Might go into the street and then go into a storm drain that goes into enclosed pipes that then carry that into either a nearby waterway, or maybe we do have a stormwater pond that it's carrying that water into it. But essentially, if you think about where that stormwater runoff is generated and then where it gets discharged, there's essentially not much of an opportunity for that water to get back into the ground. Okay? We have, and the implications here are that the increased runoff is not just a volume issue. We do have flooding that causes a lot of problems. So if you see in the upper right-hand corner, flooding is still a major issue, particularly as we think about climate change and sea level rise in our coastal and estuary areas where we have sunny day flooding and reduced capacity in our storm drains systems. But we also have channel erosion and instability of properties due to greater intensity of runoff and higher flow rates through those channels. The channels are formed over thousands of years. They basically are not used to the increased runoff that comes from the urbanized areas. So what happens is the additional flow rate and the shear or the scour that occurs with it basically cuts out a lot of that sediment and carries it downstream. But our urban areas also contribute nutrients. And so bypassing the natural infiltration bypasses some of the natural treatment that occurs with the water that would run off of our sites. So you can see in the lower right-hand corner, I believe this is the St. Johns River in Northeast Florida from several years ago, that we have excess nutrients leading to an algal bloom in the upper St. Johns River here, or the lower St. Johns. And these algal blooms can then cause issues with ecological balance, causing low dissolved oxygen and ultimately causing fish kills. So there's a lot of impacts that can come from stormwater runoff. Now, when we think about stormwater management, a lot of times, and particularly flooding, a lot of times we're used to thinking about these really large storm events. So for example, this is rainfall data or storm event return periods for, I think this data is actually it might be from the west coast of Florida, it might be in the Tampa area, but it's, it's a similar idea here. Here we have the return periods in increasing darkness of their blue colors here with the bars. And so when we think about it, we might think about, for example, the 24-hour, 25-year return period. That's 10 inches of rainfall. That's a lot of rain that we might receive. That might be like a tropical event that comes through. We also hear about sort of the 100-year event or the 500 or 1,000-year event. These are really large storm events that we're talking about here, on the orders of 10, 15, and even 20 inches of rainfall. When we think about stormwater management and the flood control, and we're typically with flood control dealing with those 25, 50, 100-year return periods as our design standard, depending on where we're at in the state. We see that a lot of the conventional approach to managing stormwater has been to get the water off the site as quickly as possible, but then to mitigate so that we don't have we're not passing that peak flow rate and that increased volume downstream so much that we cause downstream flooding. So we have stormwater ponds has been our typical solution to managing that stormwater runoff. What happens is in the landscape and the developed landscape, runoff from rooftops, streets, a lot of connectivity to direct it fairly quickly into our stormwater pipes and stormwater management system, stormwater collection system. And then that will typically, most commonly, if it's not going directly into a waterway, we'll see that that gets deposited or gets discharged into a stormwater detention pond of some type. And the intent of these is threefold. Number one is flood control. So we're trying to basically, if you think about the terms detention and retention, I like to use a school analogy here. If you get detention, you get held for an hour after class and then you get released. If you get retained, okay, retention is a little bit different. Retained a grade, you're not going anywhere. So retention captured and then held on site, detention held and then later released. So this capture of that big pulse and then slow release is one of the main functions of stormwater ponds, so that they don't have, so that they can mitigate some of this flood risk from the upstream development. So we're trying to manage the flood control and flow rate. But we've also tried to implement and incorporate water quality treatment into these stormwater ponds. And in general, the rules, the way they were set up, stormwater ponds were kind of credited, particularly from a nutrient perspective, with a sort of presumption of compliance. So if you design a stormwater pond and we have 80% removal of sediments, okay, then we'll assume that that is getting about 80% removal of nitrogen and phosphorus. And this was set up in the 80s and 90s within the state of Florida. And at that time, we thought that nitrogen and phosphorus were pretty similar to sediments in that it was a lot of particle-bound pollutant sources, so physical particle debris and so forth. We've later learned and realized that a lot of our stormwater runoff, the nutrient loadings are actually fairly dissolved. And so what we've also found is that these stormwater ponds are not really meeting that 80% load reduction or nutrient reduction that we'd like for them to do. So when we think about water quality, we're really thinking we have to kind of shift our paradigm a little bit from the water quantity side. So if we look here, this is a plot and sort of a distribution of the size of rain events that we might have, in this case, on any given day. All right, so instead of just ranking them 1 to 157 or whatever it might be for over the course of the year at the bottom here, this is just broken up into percentiles. So the percentage of storm events, and ironically, I just have to note that the bottom just dropped out outside of my window, so downpouring. So anyway, the storm that we have here, we have 80%, for example, 80% just under 1 inch. If we look at here, we see that about 85% of the day rainfall are less than or equal to 1 inch. Okay, and so what that means is that the flooding events that we're designing these stormwater ponds to primarily address, these happen very rarely. Like 90, 95, 99% of storms are smaller than those storms that really engage the stormwater pond for their peak performance. And the storms that actually we're concerned with pollutant loadings and the nutrients that are coming off of urban areas are actually these really low, really small, regularly occurring rainfall events that flush off the nutrients that accumulate in between storms. We have the term first flush, which you may be familiar with. And what this is analogous to is if you were to take sort of your dinner plate and take it to the sink and you turn the faucet on, it's going to start, the first amount of water that hits that is going to flush off a lot of the large debris or a lot of food pieces that might be on your plate. Most of it's going to wash off within that first volume of water that hits it. As you kind of continue to run the water over it, you're going to get less and less food coming off of it because there's not as much that's on that plate. Similar to the urban landscape, this first flush is sort of that small amount of water that hits at the beginning of a storm that carries most of the pollutants with it. And so these really small, the first, runoff from the first inch is typically what we refer to as the first flush, carries with it the large proportion of the pollutants that come with it. When we talk about low impact development, I want to kind of get into some of the terminology here. This is a definition that I really like from the Alachua County Land Development Code, because it touches on a lot of the different aspects that oftentimes maybe get left out of the definition of low impact development, or what we're actually trying to achieve. And so here, LID, low impact development, it's a site design strategy. It's not just one practice, but it really starts as a strategy for maintaining or replicating that pre-developed hydrologic regime. And so when we say hydrologic regime, we're really kind of talking about that very first slide that I showed you, sort of that long-term water balance. We're trying to keep the water the amount of water that was infiltrating before development. We want to keep that recharging and reducing the amount of runoff that's coming from our urban areas. And so we do use design techniques that help to create this functionally equivalent hydrologic landscape. And these practices, they incorporate storage, so capturing this water volume, infiltrating it, putting it back into the ground, groundwater recharge, plus maintaining the discharge volume and frequency. Okay, so we're kind of looking at sort of the occurrence and frequency that flow comes off the landscape, trying to match that. And integrating that, and we do this through integrated and distributed micro-scale stormwater retention and detention areas. So this is looking at really distributing, instead of sending all the stormwater to one stormwater pond at the back of a residential or commercial development. We're trying to distribute and integrate stormwater management into that landscape. And if we think about the landscape being the green area, this is our green infrastructure. So this is our infrastructure that is being achieved through vegetated areas. And so we're also looking at strategies to reduce impervious surfaces. How do we reduce our roadways? How do we disconnect some of our impervious cover? And lengthening the flow paths and runoff time. So instead of everything being piped directly as fast as we can off-site, how can we sort of capture, detain, and slow that water moving through the landscape? Other benefits that are included but not limited to include preservation of environmentally sensitive site features. So looking at what are the resources that are on the site, and how do we strategically design a development and lay out how we're going to use this land to protect natural upland habitat, wetlands, wetland buffers, and floodplains. So I really like this definition. It really captures a lot of the different aspects, the holistic perspective of low impact development in this. Kind of did talk about terminology. So you may have heard low impact development, green infrastructure, green stormwater infrastructure, best management practices, stormwater control measures. These are all sort of to an extent interchangeable terminology. So this figure here is from an article by Fletcher that tries to essentially kind of lay out, okay, what are these terms referring to, and how do they actually relate to one another? Okay, so some of these terms, for example, sustainable urban drainage systems, and one of my favorites, SQUIDs, stormwater quality improvement devices in the lower left. These are more international terms, sort of Europe, Australia. They have some creative terms there. Water sensitive urban design is also sort of an Australian term. But essentially on this x-axis, what we're looking at is kind of going from very specific structural and non-structural techniques all the way to very broad generalized principles. And then on the y-axis, what we're looking at is urban stormwater management focused techniques or intent, all the way up to sort of more broad water, integrated water cycle management, okay? So for example, stormwater best management practices or stormwater control measures are designed and really only kind of focus on addressing stormwater management. But green infrastructure might look at more holistic, broader water cycle benefits. So maybe we're trying to promote groundwater recharge and really trying to address maybe restoring hydrologic balance to a developed area or an area that's transitioning. So for green stormwater infrastructure, this is basically infrastructure practices that are designed for stormwater management. So it's intent on that, but it does provide, these do bleed over and provide some of these whole of urban water cycle management benefits as well. Okay. So when we talk about the key elements of low impact development and green infrastructure, and let me just back up real quick, one aspect to note. So we have low impact development, green stormwater infrastructure. A lot of these terms can kind of be used interchangeably. Some of them just tend to be a little bit broader, but in the context of our discussion and sort of this presentation, we're kind of interusing green infrastructure, green stormwater infrastructure, and low impact development kind of interchangeably. So key elements here of low impact development. The first one here is conservation. And so really using, looking at areas that are of high value and how we can preserve those to maintain our natural hydrology and basically prevent unnecessary disturbance of that hydrologic balance. Small scale controls. This is looking, if we think about where rainfall infiltrates relative to where the rainfall lands, oftentimes it's either directly where that water hits the ground in an undeveloped area, or it's, maybe it flows a short distance before there's a low depressional area that water can then soak into the ground. This is trying to basically mimic the natural hydrology, where essentially the stormwater management practices and control practices are small, distributed through the watershed, and close to the source of stormwater runoff generation. Customized site design. So this, with low impact development, it is sort of a customized design where it's not a one size fits all. So we need to kind of take into account what the resources and value of the site is, so that we can leverage that to integrate a more sustainable design to it. So considering as well how maintenance is going to happen in the landscape or in this developed area, and looking at ways to prevent pollution and educate the landowners or owners and operators or the public on how to more effectively manage the pollutants in that landscape. And then utilizing, again, some of the natural resources, so these natural areas that can absorb and filter stormwater runoff to where we can direct runoff to those areas, using those as the buffers that they function naturally as. So sort of an example of a compact design where low impact development was implemented. This is over in Volusia County, so sort of north, sort of midway on the just inland from the coast on the east side of the state of Florida. And on the left is what we have as far as a traditional site design. And this was the initial development plan. And essentially on the west side of this development, what was it going to be? There was a lot of wetland areas that were going to be impacted by development on this west side. And then there was some development on the east side as well, but it was sort of spread out throughout the development, throughout the property. So there was a redesign that kind of came in. They engaged with the Program for Resource Efficient Communities. There was some assessment analysis done on the development and tried to basically come up with an alternate development plan that integrated low impact development principles so that they could reduce the environmental impact on the site. So in this redevelopment, they were able to actually preserve almost all of the development in square footage that was going to be used in the traditional plan by basically, making a tighter, more compressed or compact development area up on the east side. And this is closer to actually where I-95 kind of cuts through here. And they were able to preserve these upland wetland areas. And so there were also other benefits like reduced traffic, a lot shorter commute times getting in and out of this development and so forth. So there's other benefits that can come from the, or unintended benefits in some cases, that can come from taking a low impact development approach. But they were basically able to, one of the aspects here was they were able to increase their density by looking at going more vertical with their development as well. So able to maintain, if you see there's a lot more red area here for the commercial as far as a land area, but they were able to maintain the same square footage of commercial area in a more compact design here by going vertical. That was one of the main areas as well, main changes. So with limiting, so again, trying to look at how do we change the site design so that we're limiting the amount of imperviousness that generates stormwater that we would have to then manage or maintain. So there's a couple ways that this is commonly done. So we just kind of touched on looking at smaller lots and multi-story construction. So this is a neighborhood in Gainesville where they have, basically cut the lots almost in half, if not more than that, by going to two-story construction. We've shortened here in this photo, they have shortened the driveways. So they've reduced the imperviousness that way to where you don't have this long path for each development or each lot going up to the garage. And then reducing the width of roadways and incorporating swales here. So what's happening here is so we've reduced the imperviousness by narrowing the streets. But we've also integrated nearby small-scale stormwater management adjacent to where the stormwater runoff would be generated, right beside where the street is. Okay. So getting into some of the low-impact development and green stormwater control measures. So there are sort of some non-structural stormwater control measures that are looking at the planning side and how do we design the site to limit the imperviousness. But as we get into the structural side, these are kind of probably what most people think of as, well, this is LID or this is green infrastructure. These are the practices or the way that we manage stormwater a little bit differently. Some of these are flow control, stormwater control measures, so they can kind of do capture or retention of the stormwater and retain that sort of first flush so that those pollutants don't migrate downstream. And some of these practices are more like flow through stormwater control measures. So for example, on the bottom left here, we have what is called a second generation baffle box. And I'll talk a little bit more about this in a moment, but flow comes through here very rapidly and it basically screens out and removes pollutants while flow moves through it. Doesn't really address the water volume side, but does a good job of retaining pollutants and the particles in the system. And then there are sort of off-lot stormwater control measures, but what I'm going to talk about now are sort of some of these more physical, structural stormwater control measures that folks are probably more familiar with, or I will get into that in a moment. When they're looking at the loadings or the pollutants that come from stormwater runoff, we have to consider sort of the mass reduction. So what is the mass of nitrogen, phosphorus, or other pollutants that we are concerned about addressing or managing? And so oftentimes what we typically do is we're looking at this average annual runoff volume and then looking at the average concentrations to get an estimate of what the amount of nitrogen or phosphorus might be coming off of a undeveloped area. And then our codes and laws are set up so that we reduce the increase that comes from that urbanization. So for example, here, I've got an example in the upper right-hand corner where we have a green field, and this is a term for undeveloped area. And so even though it's undeveloped, it still does, when there is runoff, it carries nutrients with it. So there is some sort of baseline nutrient export that comes from undeveloped areas. So in the assessment or design of stormwater management, we would come in and determine what that baseline or background nutrient loading is for those pollutants. Then we would look at, okay, here's what the pollutant loading is from the urbanized or the developed landscape, and determine what that loading is, and then look at basically the difference between that developed area and that undeveloped, and figure out that, basically design our system so that we would need to reduce the phosphorus in this case by 80%, and for the nitrogen by 70%, depending on certain characteristics of the surface waters. But that's sort of the approach for designing stormwater control measures for water quality. And when we think about sort of the water quality treatment, it's not, nutrients get a little more complex, okay? Nitrogen comes in 4 or 5 main different forms that we deal with, and they all kind of function a little bit differently, and how we treat them is a little bit differently. But overall, we have to manage the total nitrogen that's coming off of the site. So for example, in this graph on the left, what I'm showing is a typical breakdown of the forms of nitrogen that might be present in stormwater runoff. So you might be familiar with nitrate, ammonia, or organic forms of nitrogen, and then suspended particles, really small particles, but they stay, but they are physical particles, but they stay suspended. They don't fall out. Then we have larger ones that are settlable, and then we have nitrogen that might be bound or associated with sediment particles. So when we think about the removal of nitrogen, a lot of times we have to consider that there are multiple different processes going on within a stormwater control measure or a practice that's designed to treat or remove nitrogen. So just for nitrogen here, you know, we often think of it as a black box. What's coming in, there's a certain amount that's coming in, and then there's a certain amount that's coming out. All right, so we have some part that might overflow or bypass our practice. We have some that has been treated, and some that may be going to infiltration. But within that system, we want to optimize these processes to reduce the amount that's being discharged. So these transformations, plant uptake, trying to have physical filtration, chemical and biological absorption, trying to enhance these processes within the stormwater control measure or practice. Within Florida, we do allow for some nutrient removal credit for LID practices. And a lot of it is dependent on if they are retention BMPs or stormwater control measures. So if you see here at the top lines here, depending on how effective these practices are, they can receive between 40 and 84% phosphorus and nitrogen removal, same here. And this is mostly dependent on the volume reduction. So in general, you see that we have the same reduction rates for phosphorus and nitrogen. That's intended to be because of the overall volume that's being reduced and retained on site. We have a little bit of a difference between offline and online retention BMPs. To be honest, I'm not sure if I think I removed a slide that kind of explained the difference here. But offline BMPs, what kind of happens there is that first flush fills up the BMP, or that if you think about it as a rain garden or something that's that captures that first flush, and then any extra water, if we have a large storm that's occurring, any extra water beyond what fills that BMP would then bypass that system and not flow into the rain garden. An online system, what would happen is water would continue to flow into the rain garden or the practice, and then dilute and flush out some of the pollutants that would have come in with that first flush. So there's a little bit less efficiency there. But you can see different practices that receive different credits here. So we do have credits. So again, kind of going back to our distribution of rainfall events. If we look at sort of the runoff generating storm sizes, we see that around 80% of the days that reported rainfall, in this case for Tampa between 89 and 2019, this 30-year period, were less than 1 inch. So again, back to small volumes that occur on a very frequent basis, trying to address those. So how do we incorporate this into the landscape? Okay, so we still want to, if we're addressing these small storm events, we can't just ignore the large flood protection that needs to be incorporated into development and into protecting basically people's lives and public health. So the paradigm shift that we see here is that we don't do away with this stormwater pond, okay, or the large scale flood control practice at the bottom of the watershed. We might be able to reduce that, okay. We might be able to reduce the scale depending on how we address the design and extent of our impervious cover and how much runoff is being generated from a flood event. However, what we're looking at is how do we integrate things like permeable pavement, bioretention, cisterns, other practices into the landscape before stormwater runs off and gets into our stormwater collection system and goes downstream. So how do we integrate this into the landscape, okay? And so this essentially means that our water quality volume, our water quality treatment, the focus of that is in the landscape, whereas our flood control and our flood volume management is downstream. So for very small storms, what we might see is where we have capture of the small runoff events into the landscape with very little water that actually makes its way into the stormwater detention basin or flood control structure, okay? So kind of getting into some of these practices, bioretention and rain gardens are probably one of the more common practices that we see integrated. They have an aesthetic where we can incorporate, diverse vegetation. They can look really nice, and they can look fairly you might not even notice them if you're not sure what you're looking at sometimes. But typically these are vegetated depressional areas, and the design of these systems is that they capture the runoff and then recover that storage typically by infiltration. If we've got high water tables or a really poorly infiltrating soils, we might put in an under drain, as you see in the bottom right. That allows the water to flow through the planted soil for biological and chemical reactions to occur, to filter out pollutants. Plants can then take those nutrients up, and that water has been filtered before it gets discharged into a storm management system. Typically, we have about 9 to 12 inches of ponding storage between storm events, and we want this to recover fairly quickly, within about 24 hours. Planter boxes are a similar, or stormwater planters are a similar approach. You oftentimes will see this in highly urbanized areas where this is right up against a building or between the sidewalk and the building, as you see here, kind of the term bioretention in a box. Essentially that treatment media or that infiltration that's occurring underneath is kind of behind this short wall. One of the main things is that we want to make sure that we have any pre-treatment for suspended solids. The risk with suspended solids is that if we get too much of that accumulating in an infiltration practice, it can basically cause clogging to occur. And we want to make sure that the systems are aesthetically pleasing, because oftentimes they're in fairly high traffic areas. And with the capture and slow release, we have this reduction of that peak discharge rate. So there's some additional flood control benefits that can be realized through the use of these practices. Permeable pavements, these are actually one of my favorite practices because essentially you can park on this and it also manages its stormwater runoff. One of the misconceptions with permeable pavement, though, is that an entire area needs to be made up of permeable pavement. And that's just not the case. Oftentimes what we'll see in parking lots is that either the parking stalls or the drive path is made up of the permeable pavement, and the rest of the parking lot can be just conventional pavement. This is a benefit because permeable pavement itself is by itself more expensive than the conventional pavement. However, if you're reducing your other stormwater management practices or able to increase the number of parking stalls, it can be a cost savings for you by using permeable pavements. I show the cover page here for an EDIS document that we have for permeable pavements that you can find online. Just to kind of give you an idea, we see porous asphalt, porous concrete, and concrete pavers. These are probably the most common permeable pavement materials at the surface. But essentially, once you get below that, over a depth of typically 14 to 24 inches, the cross section is fairly similar. You have sort of increasingly larger and larger stones where water can infiltrate very rapidly through that surface pavement into the storage or that reservoir, and then slowly soak into the surrounding soil. Subsurface exfiltration is another kind of similar practice in a way. This is actually from a site that was constructed in Gainesville. And essentially what happens is you see these half pipes, very high volume that can be stored underneath them. They're structurally sound. And so what happens is you build a parking lot on top of this. The storm drains go right underneath that parking lot. And then that water builds up and then slowly sinks into the ground below it. These are called ADS systems here, but they basically, 95% void space. So there's a lot of volume there that can be utilized. Similar system here, basically infiltration trenches or dry wells. Again, this is kind of taking fairly clean water. We want to make sure that the water has been filtered of particles so that we don't have sediments within this pipe that goes underneath the ground clogging at the subsurface. Essentially what happens is oftentimes we'll route roof downspouts because that's a fairly clean source area into sort of this pipe that you see on the right. Water will fill up this pipe and then slowly exfiltrate into the gravel stone around it. A lot of void space there between the pipe and in the stone itself. Notice the fabric here that separates the surrounding soil from that stone, so we don't get sediment migration and clogging coming in. And so the water would just slowly exfiltrate into the surrounding subsoil. Vegetated swales, you're probably really familiar with these. Kind of just noticing that I'm running short on time here. So I'm kind of trying to pick up the pace a little bit or kind of wrap up here. The benefits here are that we have conveyance, treatment, and infiltration here. We can get benefits of vegetated swales. One of the main aspects here is that prohibits the use of these are existing ordinances and local government requirements for curb and gutter. And so implementing this at the local government level sometimes requires either variances or working to get those codes changed. I had mentioned the baffle boxes. This is an inline treatment system. Essentially what happens is you have stormwater heavy laden with pollutants coming in. It screens out the top here, the organic debris that kind of floats. Water flows down through the screen. Sediments kind of drop out as the energy is dissipated behind these deflectors and walls. You get additional water that overflows, a little bit more sediment drops out, a little bit more sediment removes. And then we have a skimmer here that takes out any oils or greases or removes some of those, and flow continues downstream. These are actually fairly common, very small footprint in highly urbanized areas. We have several of these around Gainesville as well. Cisterns, one of the main things with cisterns is that there needs to be an integrated recovery of the storage volume in between storms. So there needs to be either irrigation or some other non-potable use that regularly uses that water and removes or recovers that storage, so that the benefits of capturing that first flush are regularly available, and it doesn't just fill up and overflow. Green roofs are a little bit more intensive. We do have several of these. These are becoming a little bit more common in Florida. They're a little bit more intensive, or I should say, you have to design for the roof loading of the water and the plants. Essentially, these will capture about an inch of rainfall in the root zone or in the material that grows the plants and the vegetation. Water can then, any excess water will then overflow out of the system, and then plants will take up that water, evapotranspire it into the atmosphere. Just thinking about sort of the compatibility between the type of development or intensity of development here along this corridor and the different types of stormwater control measures or green infrastructure that can be integrated into those types of development. I'm going to skip this case study. I'll make these slides available. Essentially, what happens here is on the left, the conventional side, we have a stormwater pond, impervious, and looking at stormwater pipes kind of routing to all of the stormwater ponds, conventional drainage. On the right, essentially, we have porous pavement that's been used instead, and we've prevented the land for the stormwater ponds, and they're using more integrated stormwater management. Essentially, there was a lot of reduction in the cost savings through the reduction in the amount of infrastructure that was needed to put in place. So was a little, saved about 10% by going LID versus other conventional approach. Granted, this is New Hampshire, but a lot of these practices translate to Florida in our development. Operation and maintenance is key. One of my favorite quotes is that another flaw in the human character is that everybody wants to build, nobody wants to maintain. These green infrastructure practices are filters that will clog, so they need to have maintenance to remove those sediments. Plants will sort of die off over time or need to be replaced, so that's another thing. And sediments accumulate and build up. So this type of maintenance is necessary. And there's actually even a operation and maintenance for stormwater control measures national conference that American Society of Civil Engineers puts on each year, or every year and a half or so. Again, just making sure that we consider maintenance with the design, so that we don't have to do excess maintenance, and we want to make sure that the systems are recovering their volume within about 72 hours. And when you're thinking about whether maintenance, or when maintenance is being considered, it's important to think about what is the primary function of this system. What is it supposed to be doing, and then what is it not doing, and then looking at how can that be fixed. So just sort of a summary there, looking at how do we limit impervious cover. That's sort of the broad scale approach to low impact development to restore and preserve ecosystem services in the landscape and integrate those functions into that urban landscape, managing stormwater close to the source. So again, back to that sort of how hydrology was functioning before development and then requiring maintenance. Here are some sources, and I'm going to put a link to one of these in the chat. We have a series of videos that are on low impact development practices that Mark Clark and I worked with Barbara Larson to develop. There's 15 of them in all, I believe. I did mention sort of the permeable pavement EDIS document that's available. This is, here's the link here. And then we also developed, came out last year, a low impact development and green infrastructure manual for the Southeast Florida in cooperation with the Coral Reef Conservation Project. And with that, we also have sort of a decision matrix about how to design or how to evaluate which practices, structural practices, to implement based on different categories and what's needed to do that selection. So I'll put a link to that in the chat right now. So if you can check that out afterwards. And so with that, I know I went longer than what I was planning to. Sorry, I get kind of long-winded or excited about this topic, but I'm happy to answer any questions. I see there's a few in the chat here.
Yeah, thanks a lot, Evan. That was fantastic, and thanks for providing the information about those resources. That was going to be one of my follow-up questions. But I just want to, before we get into a couple of questions, I just want to post a poll here for everybody here. If you wouldn't mind filling that out, and I'll keep that open while we go over the questions. So we've got a couple here. And again, if anybody that's still on, if you go ahead and type in your questions in the chat box. And the first question is, are there statewide LID requirements, or is it up to localities to implement or not?
I chuckle at this question because kind of there's sort of a history with this. So back about 10 years ago, there was an effort to basically create revamp the statewide stormwater rule that would integrate low impact development practices and what we refer to as green infrastructure into the water management district permitting and make it a much more streamlined process. Right around that time, if you remember, there was a change in the administration, and essentially that that effort got tabled, to be honest. A lot of that is starting to come back. In the past few years, we've seen that water quality issues have been a topic that has got the attention of, let's just say it, right and left minded folks. There's no real getting around it that we have water quality issues, and people are working, and the administrations are working to find ways to do it. Along those lines, so the short answer is that no, there are no statewide LID requirements at this time. That may be coming back around though. And I will just put a plug in to note that we just got a contract, and we're in actually the negotiation of the contract with UF and FDEP to develop statewide design guidance for low impact development to help promote this, and education materials. So that will be we hope that'll be a valuable resource that will really help to promote this, and that we'll see it being integrated much more so in a lot of our developments.
Great. And thanks for that, Evan. That was great. I had a similar question myself, so I'm glad that was asked. The next question is specifically related to baffle boxes. How do you remove the built up sediments?
Yeah, let me kind of go back to that page that had that real quick, and it'll kind of help to describe sort of that process. Yeah, so what you have here is this is sort of right at the land surface, and so you see here we have hatches. These are kind of like sewer manholes, and essentially we have these really large vacuum trucks or street sweepers that most municipalities have, and what they'll do is they'll basically, I forget which way this rotates up. The screen rotates out of the way, either forwards or backwards. And they basically put in a vacuum tube that just comes in and sucks all that sediment out and clears that out on a regular basis. And they'll take away a lot of this organic debris as well. So it's a pretty quick process. It's only like about, I can't see that taking more than 15, 20 minutes at any given installation really to do all the maintenance that needs to be done.
Great. Let me see what's the next thing here. More just a comment. Someone who's here replaced their blacktop circular driveway with pavers. They're not only permeable, but according to her, they're more aesthetically pleasing.
Yeah, we see that a lot with permeable pavements. That they come in a wide variety of colors. The concrete and the asphalt, they kind of discolor over time, and they can, particularly with the pavers, you get a wide variety of colors that can that you can kind of actually do a lot of designs with it, mix and match. And if you've got the flexibility and the budget to do it, do some really pretty and nice looking permeable but solid surface areas, patios, cool. Driveways, and so forth.
Yeah, yeah, no, that sounds fantastic. So I guess it's getting back to the first question. You alluded to it, and it is especially with swales. So there's no real, I guess, uniformity, I guess, on incorporating those into
Yeah,
developed
so
landscapes. Yeah.
yeah, this was, and I think this is what you're talking about. There's not really a uniformity in stormwater requirements or what's
That's what I mean. Yes. Yeah.
community to another. There is a little bit of that. There are, at the water management district level, there are some basic requirements, but then once you get into the local governments, a lot of it has kind of been, each municipality has kind of developed their own requirements or kind of have their own um, flavor, so to speak. Uh, the statewide stormwater rule effort was the vision for that was to kind of provide more uniformity across the state, primarily across the water management districts, but still trying to provide a uniform guidance and uniform design criteria for many of the practices that could be translated to the local government. So we're trying to develop some of that so that the that resource will still be developed or still be available to local communities to implement on their own through this educational effort and the resources that we're trying to develop.
Great, great. Well, thanks a lot. No, that's that was fantastic, Evan, and we are at 1 o'clock. So if there aren't any more questions, I think that will conclude this week's Water Ambassador Seminar. So remember to stay tuned for next week's. What do we talk? Oh, we are talking about treatment wetlands next week.
Yeah.
So very much along the lines of, and even going back last week, Jennifer Pelham's presentation on alternatives to turf, leading into Dr. Bean's presentation today, and next week, Martin County is recruited an expert to talk about treatment wetlands. So that should be really great too. All right. Well, thank you so much, Evan. And thanks everybody for coming out. And hopefully we'll see you next week and through the end of August. All right.
Thanks a lot,
Thanks a
Vincent.
lot.
Appreciate it.
All right. Yeah. Take care.
You do the same.